All right, good morning. We're going to take a look at lesson 3.3. So lesson 3.3, and as a reminder, just a couple things I want to show you. Over if you go to Google Classroom and go to classwork, some things that are helpful tools are the formula chart here. And so as we deal, especially today is going to be more logarithm based, but it's in the chapter with exponential functions. And so I just want to draw your attention to exponential functions. We use these two formulas all the time: compound interest and continuous compound interest. So anytime you have that A equals PERT formula, it's when you see the word continuous in the problem, or the E stands for exponentially. So if you see the word continuous or you see exponentially written in a word problem, that's when you would use this A PERT formula, as opposed to the compound interest formula we use whenever we have a word problem that has like per, or if it says monthly, daily, weekly, a word that represents an amount of times per year. That's when you use this formula. So these are the two formulas we'll be using this chapter. I want to draw your attention to that. And also, right along with it are these Desmos pre-programmed graphs. We're going to be using a lot of those. And so I do have a link to Desmos, but specifically ones that I have programmed are listed on this link. Go to load. These are the ones we covered so far: in solve piecewise, inverse, composition of functions, regressions, and now here compound interest. You can use any of these to help you solve problems. So I wanted to draw your attention to that again. We are on lesson 3.3. That's our lesson today. If you're going through Power School Learning, what you would do, how things would look for you once this loads up, is you would go over to chapter 3 and go to lesson 3.3, and your tools would be listed here. On the number 2 for classroom, the teaching, the different things I go over, there's the formula chart right there. It's a different color blue. I did that so it stands out a little bit more.
Cognitive interruption. If you're driving a Honda Pilot, license plate 9.
Sorry about that. And down below in the different color blue, there's the pre-programmed graphs for Desmos. I put that in between number 3 and number 4 because that's where you do your homework. I thought that might be where you need that there. Okay, so welcome to everyone who's live. Let's go through and solve these problems. Number 1 says describe the discontinuities in the graph of f of x equals x squared over 9, x squared minus 9 over x minus 3. Just as a reminder, discontinuities means breaks. So when you see this word discontinuities, you're thinking, where does my graph break? So we can go graph.
Mr. Voorhees?
Yeah, what's up?
I went to print out the lesson 3.3, but when I clicked on the...
Something I want you to know about here is, so these are our resources for today. This week, we have Thanksgiving break. If you're listening to this next week, if you're listening to this in the future, maybe not. But anyways, for us, we're doing lesson 3.3 here at the front end of the week, lesson 3.4 at the end of the week, and then we have Thanksgiving break. What I have done is, since that's the end of lesson 3, I didn't think it'd be right to come back and take a test right away. So I'm going to make, instead of chapter 3 and chapter 10 be tested together at the end of this, like right before Christmas, I added a chapter 3 exam that's on its own. And what I'm going to do is I'm going to make basically an extra test for the 6 weeks. And the highest one you get to keep as your grade, and the other one drops. Here's what I'm trying to say is I don't have a class day for this. So you can take it anytime over the break. Now, you don't have to. Let me write it out this way. Chapter 3 exam. This one's going to be optional. Whoops, forgot the A there. Chapter 3 exam is going to be optional. And it's going to, if you're going to take it, you will take during Thanksgiving break. Okay, but it's optional. That's a key word there. So you can be thankful and take a math test. Now, why would I suggest taking it? Here's why. Grade will only count if it benefits you. So here's the deal. Later, when you come back, we'll start chapter 10 in December. there will be a required test. This one, I'm going to put in parentheses here, is required. However, if your test here, if chapter 3 is higher than chapter 10 test, I'm going to put in the chapter 3 grade. And then you'll get chapter 3. Then you will get chapter 3 grade. Okay, so I don't know if this makes sense what I'm saying. We will have, I'm making available 2 tests, a chapter 3 test and a chapter 10 in December. Chapter 10, we're going to be in school. Everyone's required to take it. However, if you do take the chapter 3 and you do better on chapter 3, I will replace chapter 10 with chapter 3's grade. If you don't do very well on this one, I'm just not even going to count it for you. I'm just going to exempt it. Does that make sense?
Yeah.
Yes, sir.
Okay. 2 times. You can take chapter 3 2 times. So I know it's over Thanksgiving break, but that's why I decided to make it optional and where it only helps you. So if you take the time just to take 1 test, that's all it is. I'm not giving you any other homework. If you take that test over the break, it will not hurt you. I'll only, at the end of the 6 weeks, I will only keep it if it makes your chapter 10 grade better. If it makes it worse, then I will put it on there as exempt. You'll see it, it'll say in your grade book exempt, and it will not count against you. Okay, so I wanted to tell you that. So where we are on the calendar, just so you can see from a calendar perspective, I hate how it always shows all my classes together. Where is section? There it is. Let's look at this year class period. Where we are is here. We're doing 3-3, and then we'll do 3-4 on Wednesday. This is the week you would take your chapter 3 exam. It'll end the Sunday right before we come back. We come back on November 30th, and we'll start 10-1. And you'll do 10-1, 10-2. Gosh, why does it always do that? 10-1, 10-2, and then you'll have 10-3, 10-5, and then this week we'll have chapter 10 test, and then you go off for Christmas. Okay, so that's where we are in calendar. Chapter 10 test isn't in there yet because I haven't built it for this, but this is the week for chapter 10 test right here. So that's your calendar. That's what we got today. Let's take a look at the bell ringer. It says, describe the discontinuities in this graph. And that's where I started, and I said, hey, there's breaks. And then I went off on a tangent of showing you different things that are on the schedule. So let's go look at this problem. I'm going to go to Desmos. And we're going to graph this and look at breaks. So I'm going to first show you this visually, and then we'll talk about it algebraically. So the equation was x squared minus 9 over x plus 3. And it looks like a line. And then until I zoom out, I'll see that there, check that. No, it just looks like a line. So it looks to me, when it's a line, it looks continuous. So at first you might think continuous because I don't see any breaks. However, if you remember the rules, remember there are 3 rules for domain that you need to keep track of, and domain break is the same thing as a discontinuity. Oh, x minus 3? Minus 3, there we go. There are 3 domain rules, and one of them is very important for this problem. So a domain rule, a domain break would be a discontinuity. And so let's go over the 3 rules. The first one, if you remember, is you're not allowed to divide by 0. The second rule is you're not allowed to take a square root of a negative number, so it has to be greater than or equal to 0. And the third rule we just learned about last week is that a logarithm must be positive. Now on this problem, I see there's division. And what are we not allowed to divide by?
0.
0, which means there should be a break whenever the denominator equals 0. So the domain would be this way. X minus 3 cannot equal 0. And we'd say that x cannot equal positive 3 when I add 3 to both sides. When I add 3 to both sides, I get that x cannot equal 3, which means there should be a break at x equals 3. When you look at this graph, do you see a break at 3? So here's 3. Let me zoom so I can see the number. This is 3 right there. Does it look like there's a break there?
No.
No, but if I carefully investigate it, I'm going to just highlight it and go to that 3. Look what happens. When I get to 3, what kind of break is that? What do we call that when it makes a white circle like that? Yes, what type of discontinuity? There's 3 of them. There's infinite, removable, and jump. No, infinite's when it breaks and goes to infinities. So it's not a jump either. Jump is where you have 2 separate pieces that don't meet.
Isn't it removable?
That's removable. There you go, Aiden. Very good. It's removable. So we'd say it has a removable discontinuity. Removable discontinuity when x equals 3. And that would be your answer right there. Removable discontinuity when x equals 3. Now, why, or you could call it a hole. Do you remember that term? We've also this school year called it a hole. Now, the reason why is if you factor the numerator, I see there's an x squared, so this is quadratic. If I did ax squared, let me write it up here, ax squared plus bx plus c, I could do x method. On this problem, it looks like my a is 1, my c is -9, and the b must be 0 because it's not even there. So I must have a b of 0x right in the middle. So I have 1 times -9. So factors of -9 that add to 0 are 3 and -3. So what am I saying? Factors of -9 that add up to a 0 would be 3 and -3. That means the top could factor to be x plus 3 times x minus 3. And then the denominator we had x minus 3. Do you see how these two can cancel each other out? Another name for cancel is remove. We can remove those. So that's why it's removable when x equals 3.
But the intricacies are that has a jump discontinuity at x equals 3 and they're removable at x equals -3.
So you're saying I have a typo on my answer choices?
Probably. You don't have,
So now we're taking a look at number 2. If A is the amplitude, and this says what is the amplitude A, so that's what we're looking for, in 6.15 on the Richter scale. 6.15, where is that going to go on the problem?
where the R is.
Yeah, the R stands for Richter scale. So I'll put 615 right there. 6.15 is the R, equals all this. And you could solve this by graphing. I'll show you first by graphing. If you want to do it by graphing, you could type in the whole thing. 6.15 equals 3.75 plus log parentheses, and don't use A, just use the X to solve. And wherever it hits the X-axis should be the answer. Now, as I scroll out, it's way out there. So an easier way of possibly getting that solution is if you don't see it right away and you think you might have done something wrong, if it says it's graphing, it says it's being graphed, it says it's blue, you don't see it right away, one thing you can do is divide it and put the left side of the equation as its own equation, y equals 6.15, and do another where you set the right side, I'll just copy and paste here, as equal to y. Uh-oh, shouldn't have copied. There we go. And then you would look for where these two intersect each other. Now they should all intersect at the same spot because that should be your answer. So if I scroll out, this is the intersection right there. That would be our solution. A would have to equal 251.189. A would equal 251.189 in micrometers. And that would be our solution there. Now, if you want to do this by algebra, the way you would do that Let's just see if y'all know the steps. Let's see what kind of algebra y'all know. What do you think you would do first if you were trying to solve for A? If you were trying to get A isolated, what would you do first?
Algebraic function, and basically you would subtract 3.75 from both sides.
Good. Good, Joshua, Pamela, same thing. So when I subtract that, make sure I don't make a math error here. I get 2.4. So 2.4 equals the log of A. Okay, so a question from last class. This is called a common log. When you see a log and it does not show a base down here, the base is a 10. When do you put an E? When it's a natural log, ln, that's correct. But this just says logs, that means the base is 10. The way you solve a logarithm, once the log is isolated, is you convert it to exponential. So remember, the base always comes first. So it'd be 10, and then you switch these two. So instead of 10 raised to the A, it becomes 10 raised to the 2.4 equals A. And that right there, if we type in the calculator, should give us this same exact answer. 10 to the power of 2.4 is 251.189. You can see these numbers are the same. It's just this one's rounded. This one is not rounded. So right here, this is more exact. That's 251.188643151.
We don't want to round to 251.2.
Sure. Does it say what to round to in here?
No.
No. So I'll circle this and say this is the exact answer. That's the exact answer. Unrounded. And right here, this would be called rounded, and this would be in micrometers, so I should put that in there. Micrometers, because units do matter. That's the exact answer. This is the rounded to the nearest thousandth. 3 decimal places is like, the way you do it is like 1,000. 1,000 has 3 zeros, so that means 1,000th has 3 decimal places. That's how that works. And so anyways, that's your bell ringer. Let's take a look now at the lesson.